Welcome, folks, to the 29th day of remote learning. Today we have a video lesson because I have to go into the school during our usual lesson time and help the grade 12 students who are cleaning out their lockers, make sure everything stays organized and people keep proper distancing, everything stays safe. So I won't be able to be live, but we're doing this recorded, and you're welcome to send me any questions that you have by email or through a comment on Google Classroom. So today we have 4 skills. The first one is to get a line in slope-intercept form from 2 points. So find equation from 2 points. And so we'll do a quick example here. So we've already talked about finding slope from 2 points, and that is exactly what we're going to want to do here. So if I have the point 3, I don't know, 9, and the point 6, I don't know, 4. So what is the equation of the line going through those 2 points? Find equation of the line through these points. All right, so first thing we do is find slope. So step 1, find slope. And we're often, whenever we're trying to find the equation of a line, no matter what information we're given, whether it's 2 points, whether it's a parallel line, perpendicular line, whatever information, we're often trying to find the slope as our first step. So here we have that slope is the change in the y, so final minus initial, divided by the change in the x, so final minus initial. And we're going to have a little visitor here in a moment. Oh, it's MathCat. Hello, MathCat. So, MathCat really likes pens. Let's see if we can get MathCat to stop messing with our focus here. All right. Refocus that. There we go. Ooh, yeah. Okay. So to find the slope of the line through these 2 points, we are going to look at our slope formula, which is change in y divided by change in x. It's really our definition of slope. So y from the final point, I'm just going to label these xy, xy. This is going to be our initial point. This is going to be our final point. So y from the final point is 4. Y from the initial point is 9. X from the final point is 6. X from the initial point is 3. 4 minus 9 is negative 5. 6 minus 3 is 3. So now we know the slope of our line. And so we know a point. In fact, we know 2 of them, but we're going to pick one. So we'll say x is 3 when y is 9. And we know that the slope is negative 5/3. And we know that a line is in the form y equals mx plus b, unless it's a vertical line, but we're not worried about that right now because these 2 points have different y values, so it's not a vertical line. Okay. So now we're just going to sub in the x value, the y value, and the m value into our formula. So it's y, which is 9, equals m, which is negative 5/3, times x, which is 3, plus b, and b we don't know. And then we're just going to solve this equation. So this is step 2. Should have written this earlier. Sub in. And then step 3 is solve for b. So I'm going to change that 3 into a 3 over 1. So that way I have a fraction multiplication here. Fraction multiplication is going to be top times top, which is negative 15, bottom times bottom, which is 3. By the way, you can do this and then reduce, and that's how most people would first think to do it. But it's actually a lot more efficient to go, okay, 3 divided by 3 is 1, so this is just going to be negative 5. So we'll see here in a second that that's exactly what we get. Negative 15 divided by 3 is indeed negative 5, plus b. Add 5 to both sides. And we get 14 equals b, or b equals, stay on the screen here, b equals 14. And then step 4 is to conclude. And in this case, that just means writing the equation y equals negative 5/3 x plus 14. And so you might ask, well, why do we put in the values for m and b, but not for x and y? Well, x and y are different for every point on the line. This equation is relating a specific x value to its y value for each point on the line. So if you put in any x value, you get the y value that makes that point be on this line. That's why this equation exists. So we don't want to put in an x and y value because there's infinitely many of them that we could try. And whatever x value we put in, we can calculate y, or whatever y value we put in, we can calculate x. And the one we calculate will always make the point be on the line. But for that, we need the slope and we need the y-intercept, and they're always going to be the same because they're part of that relationship between x and y values. Okay, so that is slope from 2 points. The second one we're going to look at is converting. So we're going to look at converting to standard form. And in grade 10, you're going to learn about finding points of intersection of two lines without having to graph them the way we have this year. And standard form is going to be really helpful for that. So as a recall, standard form is ax plus by plus c equals 0. Some people say that the coefficient of x, which here we're calling it a, has to be positive or 0. I'm not super picky about that, but some people are. But what I am super picky about is no fractions. If you have fractions, it's not in standard form yet. And it has to be equal to 0. So you can see that right in the equation, so we don't really have to write it, but I'm going to put it here anyway. So those are our rules for getting standard form. So let's look at an example. So why don't we take the one we just looked at, y equals negative 5/3 x plus 14. I want to turn this into standard form. So the first thing I want to do is I want to get it equal to 0. But right now there's a y over here, so I'm going to subtract y from both sides. Negative 5/3 x plus 14 minus y. Y minus y is 0, which is exactly what we want. I'm going to actually skip a line here. And now I have this fraction, negative 5/3, and we're not allowed fractions. So I'm going to multiply the entire equation by this denominator, both sides. So 3 times 0. Over here, we're going to go 3 times negative 5/3 x plus 14 minus y. And there we go. So everything multiplied by 3. So 3 times 0 is 0. Here we're going to do our distributive property. So 3 times negative 5x, or negative 5/3 x, pardon me, plus 3 times 14, plus 3 times negative y. And we'll continue this up here. We'll get 0 equals 3. Well, that's like 3 over 1. And here we're going to speed it up. Just like I said above, we can cancel these 3's because 3 divided by 3 is 1. So this just leaves negative 5x. 3 times 14, I'm pretty sure that's 42. And 3 times negative y is negative 3y. Now suppose I was one of those people who is picky that a, the value of the coefficient of x, has to be greater than 0. There's 2 ways you can do it. One way is to move all of these terms over to the other side and get the 0 over here. The other way to do it is just to multiply everything by negative 1, because that's just going to change all the signs. So negative 1 times 0 is 0, negative 1 times negative 5 is positive 5, x stays, negative I'm actually going to change the order here. Negative 1 times negative 3 is positive 3y, and negative 1 times 42 is negative 42. And now we have ax plus by plus c equals 0. So there you go, converting to standard form. All right, I'll pause it there if you need to continue to take a look at it, but I'm going to flip and go to the next side. Next skill is slope from standard form. So how do we take standard form and get slope intercept form? So I'm actually going to continue to use this one here, 5x plus 3y minus 42, because that way it's easy to check our work. So 0 equals 5x plus 3y minus 42. And we want to convert this to slope-intercept form. So we want to get it in the form y equals mx plus b, slope-intercept form. So we need the y all by itself on one side, so I'm going to move the y over. So I'm going to subtract 3y on both sides to make it go away from the right side and end up on the left side. So plus 3y minus 42. So I've subtracted 3y on both sides, keeping it equal. Whoa. And we are not focused. There we go. All right. So slope-intercept from standard form. There's our standard form line. We want it in slope-intercept form. And to move this 3y over here and get the y by itself, I've subtracted 3y on both sides. So negative 3y equals 5x, 3y minus 3y is 0, minus 42, divided by negative 3, divided by negative 3, divided by negative 3. So I'm dividing everything, both sides, by negative 3. Negative 3 divided by itself is 1. 1 times y is y. 5 divided by negative 3, well, we can move the negative to the numerator of the fraction, so we get negative 5/3 x. And then 42 divided by 3 is 14. Negative divided by negative is positive, so we have plus 14. So we've taken our standard form equation, we've transformed it to y equals mx plus b. And we can verify this because we started with this and turned it to standard form in the last question. And you can see y equals negative 5/3 x plus 14 was indeed our starting point. And it's what we've got back to. So that confirms that for us. The final question type that we're looking at today, and again, feel free to pause, go back, rewind if you want to hear the explanations again. But the final type for today is parallel and perpendicular lines. And so we did some work where we were building the equation of a line, knowing some information about its parallelness or perpendicularness. Here we are going to just look at, are two lines parallel? Are they perpendicular? Are they neither? And we're actually going to add one little extra piece, which is, are they the same line? You know, they're not just parallel, but they're actually the same line. So parallel lines, same slope. So if one line has a slope of 5 and the other line has a slope of 5, those two lines are parallel. If one line has a slope of negative 3/17 and the other line has a slope of negative 3/17, they're parallel. If you have two lines and one of them has a slope of 7 and the other one is parallel to it, the other one will have a slope of 7. So parallel lines always the same slope. Perpendicular lines, well, they're a little bit different. So we say that the slopes are negative reciprocals if the two lines are perpendicular. And that's a fancy way of saying flip the fraction and change the sign. So I'm going to give you some examples. So if we have, say, y equals 2x plus 900, m equals 2, the perpendicular slope is going to be, well, 2 is like 2 over 1 as a fraction. If I flip that fraction, I'm going to get 1 over 2, and then I have to change the sign. So it's positive, I'm going to make it negative. If I had, give you another example, y equals negative 7 twelfths x plus 1. Well, my slope is negative 7 over 12. If I flip that, so perpendicular slope, I'm going to get 12 over 7. And this was negative, so this one is being changed to a positive. And so two lines with these slopes are perpendicular. So the types of questions you'll see is for the pair of lines, y equals 3/5 x plus 12, and y equals negative 5/3 x plus 3. Are they parallel? Are they perpendicular? Are they neither? Or are they just the same line? Well, when you do this, always start by arranging the line into slope-intercept form, because you need to see the slopes, and we kind of need the intercepts for a little piece of this as well. So if it's in some other form, rearrange it, get the y by itself on one side, and simplify everything else down so you have y equals mx plus b. And then once you can see the slopes, then start your evaluation of whether they're parallel or perpendicular. So in this case, I look at the two slopes, 3/5, negative 5/3. If I flip 3/5, I get 5/3. And if I change the sign, I get negative 5/3. So these two lines are perpendicular. So here is a different one, 7y plus 2 equals, let's go 4x. Oh, sorry, instead of 2, let's go 28. 7y plus 28 equals 4x plus 14. And y equals 4/7 x, let's say minus 2. Okay. So are these two lines parallel, perpendicular, the same line, or none of the above? Well, the first thing we need to do is get this one transformed to slope-intercept form. So I'm going to subtract 28 on both sides. And 28 minus 28 is 0, so 7y is all that's left. 4x, 14 minus 28 is negative 14. And since I want y equals, not 7y equals, I'm going to divide by 7 to make the 7 go away. Everything on both sides. 7 divided by 7 is 1. 1 times y is y. Here, 4 divided by 7, we're just going to leave it as a fraction. And I want to emphasize this. A lot of people will try to turn this into a decimal. We don't like decimals. We like fractions. Changing this to a decimal will get you an infinitely long decimal. It'll mean you have to round it, you'll lose accuracy, and you'll make your calculations harder. So just leave it as a fraction, make your life easier. 14 divided by 7 is 2, so we get minus 2. So now this top equation has been transformed into slope-intercept form. If I compare the two equations, I see I have the same slope. So they are parallel. But I also see that I have the same y-intercept, which means they're actually the same line. Obviously, a line is parallel to itself, but because they have the same y-intercept, they're not just parallel, they're also the exact same line. So these two here, same line. Okay, so feel free to hit pause, to go back, rewind, rewatch different parts of this video. If there's something that's not making sense, send me an email. I'll help you out. I hope that you have a very good rest of your Monday. Take good care.